Give this one a try, see what you can do. I'm going to solve it now. You want the min and max values of some function. The first thing you got to realize is it doesn't want to know where the min and max values are. It wants to know what the min and max values are, meaning it's looking for f of x values. And another thing to know is that there's only really two ways you can have a min and max value in a function. You can either, like let's say this is our function right here, right? Some little staircase. Well, that part's screwed. Yeah, good enough. And your interval will be this red section here. You can have peaks, and then you could take the derivative and find the derivative equal to 0, and you can find out where those peaks are. That's one way you can have a min and a max. Same thing with the min, like looks like this is a min. But you can also have certain endpoints that may be the min and max, and they don't necessarily have to have a 0 slope. Okay, those are the only two situations you can have a min and max. Like in this function, actually, I was just kind of drawing it randomly, but it turns out that just by eyeballing it, it looks like both the endpoints are the min and max, because this point is probably a little bit higher than that point. I don't know. So you kind of see the idea, though. You could have a situation where the peak here, where the derivative would be 0, is the actual minimum. So it just depends on the problem. The way you figure out which one truly is the min and max is you find all of them. So to find the min and max, we need to find the endpoints and the points where the tangent line is 0. And this could also be considered local min and max. Okay, so we need to find the endpoints. We need to find the tangent line is 0. So let's find the local min and max. We'll call this the local min and max. Okay. So to find the local min and max, you would take again, you're looking for the tangent line, right? So you want the derivative. Remember, the derivative of any function is going to be the tangent line. So we take this value f prime of x, very simple derivative here. You're going to multiply that 3, it's going to be a 12x squared. You're going to multiply this 3 by 2, it's going to be a 6x, and that 2 is going to be left to be a 0. So there's your function. Now we will set this value to 0 because that's what we're interested in, where the zero value occurs. 12. We can factor out an x here. And then we'll have one solution will be x equals 0. And then the other solution will be 12x plus 6 equals 0. X will equal negative 6. We're subtracting that 6, and we will divide by 12. X will equal negative 1/2. So at both of these points, we have either a local min or a local max. So we'll plug in both of these points to our original equation. Just rewriting the equation. So now we'll plug in 0, for example. F of 0 equals 4 times 0 plus 3 times 0. This is a cubed, that's a squared, plus 2. So f of 0, that's 0, equals 2. F of 1/2, negative 1/2, excuse me, equals 4 to the negative 1/2 cubed plus 3 to the negative 1/2 cubed plus 2. This will equal negative 4 over 8 plus, that'll be a positive 3 over 4, and that'll be a positive 2. When you add these fractions, you will end up with 18 over 8, and that will equal 2.25. So now we have found that local min and max at 2 and 2.25. We don't know which of these are min and max, but we do know that they are min and max. If we wanted to find which is a min and which is a max, we could take the inflection point, which would be just the second derivative of the function, and if it's negative, it'll be a downward inflection, meaning it's a maximum. But we don't really need to worry about that because we can just find the highest and lowest values of all the things we collect and go from there. So now we will find endpoints. Okay? So the way we find the endpoints is we'll again take our original function. I'm going to write it again. I'll put the equals fx over here. So we will plug in the points on the interval, the very last points on the interval. And we are again working, we're working within the interval -2 and 2. We're working on the interval -2 and 2. So let's do f of -2 first, because why not? Plus 3, -2. I'm working a little quickly here because this is pretty simple plug and chug stuff. This will result in -32. This will result in a +12. This will result in a +2. F of -2 will finally come to -18. Now we'll plug in f of 2. Times 2 cubed plus 3, 2 squared plus 2. So we had some competing numbers here because you have some negatives and positives. This is all positive numbers, so you expect this to be a bit larger. This will be a 32. This will be a 12. This will be a 2. 32 plus 12 plus 2 is 46. Okay, so now list all values. Okay, so we have a -18, we have a 46, we have a 2.25, and we have a 2. We have a 2.25, and we have a 2. Now we will find the highest and lowest values of these numbers. The highest and lowest values are here and here. So our max and min within the interval, max and min in the interval -2 to are -18, 46. In this case, they ended up being both the endpoints. The max and the local max and min didn't really matter. And just to show you, I also put it in Desmos, and you can kind of see our interval was -2 and 2. Here's our local max and min at 2 and 2.25. Clearly, By the time you get down to 2, it's much lower. You get this negative 18 value that we had, and you also get the 46 value that we had. Thanks. Hope you got something out of it.